And we'll go ahead and keep rolling through so we can get through all this material. There's a lot to go through. It's an amazing piece of equipment, but there is a lot to go through on there. And let me just take a look at my questions here before we go back. Okay. Yeah, what happened, the PDF I gave you was the right one. I just accidentally grabbed an earlier version of the PowerPoint. I should just go ahead and delete that one, and then I don't have to worry about accidentally ever doing that again. All right, we'll do that later. Let's keep rolling along here. So wireless, we can configure our IP address or statically. Roaming threshold. So one of the things that's nice is as we're taking this out and doing testing, we can see that it roams from one AP to the next. So if I go in here and I configure my roaming threshold, this is equivalent to my receive sensitivity on a device. So let's say I have a device, I've got a little communicator I'm using, a cordless phone, a PC. Those devices have a receive sensitivity level, which says that to get this data rate, I have to have this signal strength. So what I can do is I can come in here and configure that on my OneTouch AT G2, and as I'm walking around, if my signal strength drops below this value, then we will try and roam to the next AP. So this helps us ensure our roaming is working properly. Authorization default. All this does, well, I hate to see all this does because it's pretty cool. But what this does is this indicates whether a device is authorized to be on our network or not. Now, this is strictly informational. So here's the way we set this. If the majority of the devices that you discover belong on your network and are authorized, set this default authorization to authorized. If the majority of the devices are unauthorized, set it to unauthorized. We can manually go in and change the designation on a per device basis. This just says what are we going to default it to. So we want to do as little work as possible. So if we can default most of them to authorized and just pick out the unauthorized ones, that's great. But really this is a visual indication of devices that are authorized and unauthorized. Okay? Transmit probes. Normally we're going to transmit probes and look for wireless networks. If we're doing a security audit and I don't want anyone to know that I'm out there looking at the wireless network, I might turn off transmit probes. This causes the OneTouch AT G2 to be quiet. It just listens. Otherwise it is transmitting packets. And if you have, somebody brought up an AirCheck, if you have an AirCheck, we can do this on the AirCheck as well. And again, for doing wireless network audits, this is a very nice feature. So this ensures that people don't know that we're out there. Here's our wireless signal adjustment. So we can go in and adjust our signal by band or channel. Now, this will meet specific needs. This is not something that I've ever actually had to go in and change as part of the testing. But if you found yourself in a situation where you needed to be able to go in and change those settings, it's in here and we can change that. We can also change our noise floor. So again, not something we would normally change, but if you were in a situation where you found you needed to change that, well, it's there for you so that you can change that if necessary. Okay. One of the questions that came up, will the OneTouch AT show the handoff when we roam? We're going to see that in the log information. Okay. So one of the questions, it's not always possible to set or view that threshold on the end device. A lot of this is we're going to need to get from the wireless card manufacturer. Most of them will produce a receive sensitivity, tell us what the receive sensitivity of the device is, or what signal strengths we need to receive, and some manufacturers do. So I found that In some hospital environments where they did have these little communicators that the personnel could wear, that they told us that the receive sensitivity was -72. So we had to have a -72 signal strength or better. So in that case, we could program that in. So this again is one of those things when it comes to that roaming threshold. If a manufacturer has gone in and given us that information, we can then put this in and create a specific profile for that particular receive sensitivity. All right. Analysis. One of the things that's nice with this piece of equipment is it will use SNMP version 2 and SNMP version 3 if it's available. So we can go in and we can turn on SNMP version 1 and 2, and we can turn on SNMP version 3 if we're using it. And we can come in and put in our community strings. Now these community strings are space delimited, so we can put in multiple community strings in here if we have multiple community strings configured on our equipment. We're going to find out that when it comes to doing things like path analysis, having that SNMP community string in there becomes very important. And we'll take a look at that as we dig in. All right, so that is, I'm just going to come up and check on my questions here. That is how we go in and do our basic configuration. So now let's get in and really start digging into the meat of what we can do with this piece of test equipment. So as we saw, if we haven't configured anything yet and we hit test, we see something like this screen that we have right here. If any of these tests fail, we're going to see a red X on there. So like I mentioned before, if we had told it to use PoE and we didn't have PoE available, then that shows up as a fail. So I'm just going to flip over here to my non-PoE connection. We're going to run the test and I'll show you what a failure looks like real quick. All right, so in this case, we see that we failed on our PoE and we get that red X down there. And when we're all done running our test, we get a red bar up here at the top. That tells us that at least one test failed. We could come down here and take a look and see what that was. So this is our basic test where we haven't configured any additional tests yet. So if we touch the OneTouch AT icon, we're going to see some information. So what I'm going to do is I'm just going to swing over here, and down here at the bottom, we can see that we got an address of 10.0.0.179 on our wired side. On our wireless side, we got an address of 10.0.0.201. So right here on the front screen, it shows us those addresses. If we're using a VLAN tag, that VLAN tag will be shown right above the IP address. So if I touch that OneTouch AT, it shows me right here. Here's the IP address I got, here's the IP subnet, my IPv6 information, MAC address, management port IP address, unit name, and I can scroll down and it's going to give me some information about the receive statistics, FCS errors, etc. for my OneTouch. And I could hit page down through there. If I have an SFP inserted, it's going to show me my SFP information. Now, one of the things about SFPs, and I'll see if I may not have a slide on that, but we'll grab a fiber cable, I'll drag that in here, and we'll take a look, but it will show us what our signal level is for our SFP. In fact, we may get fancy. I've got some attenuators. I'll show you what it looks like when it gets attenuated. Here's the information on our wireless side. So if I click on this, it shows me my wireless information. And I can page down, it gives me some basic information about my connectivity of my OneTouch AT G2. So we can see there's our wired information, there's our wireless information. If we touch the cable on that screen, it's going to show us our cable information. So the other end of that cable can be connected to a WireView wire mapper. Now that WireView wire mapper is a little device that we can plug in to the far end of the connection. Now if it is plugged into that WireView wire mapper, it will tell us what WireView wire mapper we're plugged into. This is a great way to go in and map out various connections in our environment if we don't know where that cable runs. Okay. It can be unterminated, and in that case it's going to give us an idea of how long is that cable. Or it can be connected to port B of the OneTouch AT. So for example, if I had a cable, and well, here's someone, we'll let that autofocus fix back on me. Here's some cable that I just grabbed off the floor here of the studio. So if I came in, let's switch over here to our OneTouch. Oh, by the way, here's our 10 gig module right there. It's got the 10 gig interfaces on it. So we'll set that off to the side. So I can come in here and grab this. I'm going to plug this in to ports A and B, just like that. And we're going to come to our home screen right here. And let's switch over. And I'm going to hit test. So we're going to run a quick test. So in this case, all we've done is connected this cable from port A to port B. Now, there are some times when we're troubleshooting problems, doing our network troubleshooting, we just need to know, is this cable that we're using any good? And in some cases, that cable may not be any good, and we'd want to know that. So in this case, the OneTouch AT G2 is connected to our wireless network. It's coming in here and running this test. We're going to see that when this is done, we get this loop right here. That tells us that we've looped that cable between A and B. And when I click on it, it shows me right here, I have a split pair situation between 1, 2, and 3, 6. This means that somebody wired this cable up that did not follow the 568A or 568B wiring standards. This cable is no good, and it's going to cause me problems. Now, if I used a cable tester that strictly measured continuity, this cable would appear to be good. But this cable has been improperly wired, and we failed on that. So this is the type of thing that we can use this to do to quickly test a cable. So would I use it all the time for testing a cable? No. It's a very powerful tester for just testing to see my patch cables are good. But if I'm going in to troubleshoot and I need to make sure at a physical layer things are working properly, this is going to give me that type of information. So we'll go ahead and unplug that cable. From there, we'll throw that back on the floor because that's where that cable belongs. Okay. Switch back over to me. We're going to plug our PoE connection back in. Okay. Let me just take a look here. I love the questions. That's why we're here. Okay. So it says, what kind of reflectometry test can be done here? So what this will do is, I'm just looking around, see if I have a nice long chunk of cable. I will find, well, let me step off camera again. I'll walk over here. This is a nice thing about having all kinds of stuff to play with out here. And also, I like everyone to know that I'm serious when I say that if you have a question and I can demonstrate that to you, then I am going to do that. I don't want to burn up too much time of our class, but also I want to make sure that you see what you can do with it. So in this case, I just grabbed this coil of cable out of one of my boxes I use for testing. We're going to plug that in, and we're going to go to home, and we're going to hit test. So in this case, we have a unterminated cable right here that we're connected to, and we are going to run our test. We're going to see what kind of test results we get back from that. And in fact, you know what? I'm going to hit stop. And just as a demonstration of how we can go in to kind of speed things up, In this case, you know what? I don't care about Wi-Fi. So I'm going to hit home and I'm going to hit test. So we're going to go ahead and run that, and we're going to turn off the Wi-Fi portion of that just to be able to get that test to run a little bit faster. All right. So while that's running, we're going to switch over here. So what we find is this helps us identify the length, shorts and opens, split pairs, and that just happened to turn out, I didn't even know that was a split pair cable. That test just happened to turn out great for that. And if connected to port B, it will attempt to link at 1 gig. So it's going to see if we can do 1 gig through there. So our test is done. That tells me that that cable is 50.2 feet long. So this does do a TDR test in that it's going to send a pulse out on this cable. We don't have any way to change our things like our nominal propagation or nominal velocity of propagation. So if we have different types of cables, our length is going to come in pretty close. We're assuming that our MVP is pretty consistent for this cable. It's not going to help us identify where any faults are along the cable. So if we look at that particular piece of cable, it's going to tell us that all of our pairs make it through all the way. Now, if we had a pair broken along that path, then what we would see is that that would show us the length to which that pair goes. So if along the path we had a broken pair, this is going to help us identify how many feet out is that broken pair. But it's not going to show us things like, you know, our crosstalk and things like that. So, but still, very handy tool for helping us identify where we might have a break along the path. So if I can't get a good link, let's say, for instance, you were connected to a link that is supposed to give you gig, but you only got 100. We could use this with this cable test to find out, do we have a problem with pairs 3, 4, 5, or 7, 8? Because if those pairs aren't available, we can't do gig, but we can still do 10 or 100. So we can use it for helping us identify problems like that. All right, so we'll go ahead and we will unplug that cable. We'll come back in here. We'll get rid of that cable as well. Okay, so we're going to go back to this cable here. Let me just, okay, that's my non-PoE cable. Grab my PoE cable. We'll get set back up again. So as far as your TDR goes, you can tell how long that cable is, and if we have any broken pairs along the path, we can find out where that's at. Okay? All right. Let's go back to home. Let's go back here. So pretty nice. This is something I really love about this. And that is that if we go to link, so we're going to come back, and I just, you know, I keep going back and showing this. I want to show you how this really works. I don't want to kill you with PowerPoint slides, but show you, you know, the actual instrument. But if we come in here to link, it says advertised speed 10, 100, 1000. The OneTouch decodes the fast link pulse. It comes back and tells us this is what the device at the other end says it can do. This shows us what we are actually doing. So in a case where we had a problem with the cabling and we were not able to do gig, but the switch was telling us it could do gig, this gives us an idea of what that problem could be. It tells us what our advertised speed and duplex is. So this tells us half full. In this case, it says our actual is full. So if time allows in our presentation today, we will go in and we'll take on our little switch that we have here. We will force that to 100 full. We're going to take a look and see what this shows us. But this is a great way that if we are running into duplex problems, if we're running into auto negotiation issues, we can use this as a way to find out what the device is advertising. This is what it is doing, and that's what I love about this test equipment. We can use this as a way to identify exactly what that device at the other end is doing. Now, as far as power levels, this is showing us our levels normal and our polarities normal here. If we did have an issue with that, we could see that this was low. And at the next break, I'll bring the fiber in here and we'll plug that in and I'll show you what the power level looks like on the fiber. Okay, now if PoE is enabled, our power over Ethernet information is displayed. And I showed this to you earlier. And this shows us our requested and received class of PoE, shows us our power source equipment type, shows us our voltage, what our unloaded voltage and our loaded voltage is. That's our true power. So true power, and I need to fix that. I'll fix that. Right now. Our true power, in this case, is it's going to show us what our loaded voltage is. And it shows us what pairs were used. So, what do we care about PoE? Well, in this case, this shows us our various classes of PoE. So for 802.3 AF, we have class 0, 1, 2, and 3. So this tells us what our power range is for each one of those classes. Tells us what our description is. Now if we come down here and we say for 802.3 AF or AT type 1, that here's our power at the powered device. Okay, so that's at the end of the cable. Power delivered by the power source equipment. Voltage range at power source equipment and voltage range at PD, our powered device. So what this is telling us is that if our voltage falls below 37 volts, we fail. Now what the OneTouch will do is it will attempt to find out what is the maximum amount of current that we can draw and still get a voltage that is sufficient to give us our voltage that we need. So what we'll find is if we put this on a link where we have a bad cable, and I'll see if we can grab a bad cable here for power over Ethernet, but this will show us in that case that maybe we could only get 6 watts. So that would tell us if we needed 13, we could only get 6, we fail. But maybe because we're plugging a voice over IP phone in and we only need 2.5 watts, 6 is more than enough. So this just gives us an idea of what our resistance is, etc. I recently ran into, not recently, a number of years ago, we ran into a situation where our power over Ethernet was failing. And after we did some testing, we found out that when we used our cable test equipment, our return loss was failing, and it showed it was our cable. Turned out to be copper-cladded aluminum wire. Now, I was in Singapore about a year or two later, and one of the folks that was doing a cable certification class handed me a roll of cable. Said, "Can you tell me what's wrong with this?" And I said, "Absolutely." I said, "That is aluminum." I said, "Wow, that's pretty good." Well, that's because I'd been exposed to it before, but we do find that some manufacturers will break the rules by doing things like using aluminum wire, copper cladding it, and even going so far as to putting blocks of concrete in the boxes of cable so that you think it weighs enough. So we got to watch for that, and by being able to go in and validate PoE, great way to do that. So our switch information. So if I came back over here and I clicked on my switch, it says, hey, we're connected to storeroom switch 2 interface gig 4. So how do we know which interface we're connected to? Well, the OneTouch AT G3 listens for CDP, our Cisco Discovery Protocol, LLDP. So this will allow us, and that's our link layer discovery protocol. So with LLDP, CDP, it's going to tell us over the wire what packet or what port we're connected to. If we cannot get that via those protocols, we will use the simple network management protocol, SNMP, to figure out where we're connected. Beautiful thing here, you walk into an office, a cubicle, and we don't know what switch port that's connected to. You don't have to go through and tug on cables. We plug this in and it will tell us what port we're connected to. Either we have to have CDP turned on, LLDP turned on, or we have to have SNMP access to that switch at the other end. That'll give us some information about that particular switch. Okay. Now, in addition to using our link level discovery protocol, Cisco, it does support the Extreme Discovery Protocol and Foundry Discovery Protocol as well for using that equipment. So as we go down, it shows us what port we're connected to. If we can communicate with that switch via SNMP, it'll tell us the name of the switch, where that switch is located, etc. So I was on a troubleshooting job. We went into the wiring closet. All the labels had fallen off the switches. It got so hot in there, the labels fell off. So they said, well, we're going to have to get a console cable to figure out what switch we're connected to. And no, we don't. We just plugged the OneTouch in there, and we were able to tell what the IP address was of the switch without that. So one of the questions is, what about, well, let's see, I got to put my glasses on, UDLD. That one, I don't know. And so what I'll do is I usually go back through these questions and we'll take a look and see on UDLD. That was not listed as one of the protocols that's supported by the OneTouch. So I'm going to say right off, it probably is not, but we can go back and take a look and see if it is. Now in our Wi-Fi connectivity, so if I came over and took a look at my Wi-Fi connectivity information, what this does is this tells me right here, I'm connected to my office Netgear wireless access point on channel 36. Now because the OneTouch AT has 3 radios in it and supports up to 80 megahertz bonded channels on 802.11 AC, it says that we are connected, our base frequency is 36, but we are bonded to 40, 44, and 48. Our security is WPA2 personal. Here's our IP address. Here's where we've been connected. And it will show us our log information. So last week, I was doing a little project with a friend of mine at his organization, and we could not connect to the wireless network. Why can't we connect? So when we looked at the log, we would see that we would go in, we would do our 4-way handshake to connect, and then we would get a deauthentication from the wireless access point. So every time we got that deauth, we went back and we did the first of the 3 R's, right? The 3 R's are reboot, reimage, replace. We did the first of the 3 R's, we rebooted the AP, and all of a sudden we could connect. So we know that that AP was sending us deauths after we did our 4-way handshake. But our log right here tells us that process. So if we cannot connect to our wireless access point, this gives us that information on why we couldn't connect. Very powerful information in here when it comes to troubleshooting why we couldn't connect. Okay. All right. Let's swing over here. Gateway. Click on our gateway. It's going to show us information on our default gateway. Shows us both on the wired and the wireless sides. Okay. DHCP. So this shows us our DHCP information. So in this case, again, on both the wired and the wireless sides, it tells us what the server was, tells us the server MAC, server name. How long did it take it to give us an offer? So it took 51 milliseconds. We accepted that. Now if we come down here, this section down here, offer to, if we run this test and we see that we got a second DHCP offer, this could be one of 2 things. One is we could have redundant DHCP servers, but this could also indicate we have a rogue DHCP server out on our network. So the OneTouch will listen, and if we get more than 1 DHCP offer, it'll let us know that we received more than 1 DHCP offer, and it will tell us what DHCP server tried to offer us that address. So this is a great way of identifying rogue DHCP servers out there on our network. DNS, this is where I can come in, and in this case we've got enterprise.netscout.com set up. It could be you don't care if you can get to that address. We can change this. You can go into the DNS test, go into setup, Come in here, go into DNS. Well, in this case, it's still got an old one in there. So I'm going to change that. I'm going to say I'll say done. I could say test again. So in this case, we went in, we did our lookup, and we were able to resolve that address. So in this example, we can come in here and we can change those to whatever addresses we want. So probably something within your organization, or could be something out on the internet if that's where you wanted to be able to test that. Okay. So in this case, we see that we connected, but it says our level is low for our Ethernet signal. That's interesting. All right, those are our basic tests. So those are the tests that we're going to see get automatically run every time we do our tests. So let's go through and we're going to set up some user-defined tests. So this is where we can set up our own tests for our environment. Now the user-defined tests allow us to customize the OneTouch AT to test things like web servers, applications, throughput, Wi-Fi performance. Tests are added by touching and holding in the upper area of the screen. All right, so let's take a look. Let's go back to our home screen here. So what I can do is we have, private internet, we have public internet. So, or intranet and internet. Does not matter where you put things. This is more just to give you a graphical or a visual view of where things are at. So if I came in here and clicked and held, it brings up my add test screen. So I could start out by saying ping. I could say I want to ping a server. All right, well, I'm going to ping 10.0.0.145 as my DNS server. Now you notice up here at the top when we set this address, it says IPv4, IPv6 URL. What that controls, we can type in an IP address if we want, but what that controls is these buttons right here. These buttons are to make life easier for us if you're using the touch screen. So I could come in, let's back up. Let's say I wanted to put in my website. I could say www.nps-LC, and then I could hit .com. Just makes it a little bit easier to type that in. Now if I back up and I type IPv4, now it makes this easier, 10.0.0.145. You don't have to put in the leading zeros. It does that for you. And I'm going to hit done. So now we've come in and said we're going to ping that. Now, I could type in a descriptive name. And I recommend doing this so that way we know we could say local DNS. I'll hit done. Now we can configure some of these parameters. And if we were going to do things like change the size, we could set the don't fragment so we could test the MTU along the path. But we're done setting that up. So now we see that ping is now there under local DNS. So I'm going to hit run test, and I'm going to come down here. So one of the questions is, I have redundant DNS servers. So is it going to check a third server? Unfortunately not, but here's the cool thing. When it comes to packet capture, we can set this up so it'll do a packet capture every time we run our auto test. So every time we run this test, it'll do a packet capture and it'll save that packet capture. So we could go in and do a packet capture and be able to see that. But right now, the way it's set up, it's only going to show us the first two DHCP servers to respond. So if your rogue server responds before your redundant or even before your primary, we're going to see that, but it's only going to show us the first two DNS servers to respond to that. Okay. And as far as DHCP options, right now there isn't a test to check DHCP options, but I like that. That's a good one. When I go through the questions, I'll make sure to put that one in there as something as well. All right, so in this case, we were able to come in and we were able to ping our local DNS server. So that's great. Love that. We were able to ping. So ping, I just walked through that. We can set up as many pings as we want just to make sure that these resources are available. Like I said, if we crank the frame size way up and set the don't fragment, this is a great way to make sure that our MTU is working along the path. Connect via TCP. So I want to make sure that devices on my local network have certain TCP ports open. So let's flip over here. And I'm going to click on this. I'm going to go connect TCP. And I'm going to say 10.0.0.60. So that is my network attached storage. I'll say done. Now that does have port 80 open, but you know what? We're going to also say NPS NAS. We're going to say that really I want port 443 or 445 open on that for SMB. All right. And I'm going to come back here. And you know what? Uta, that works with me, she has my redundant NAS located at her office. So I want to make sure that one's available too. So I could say 10.0.12.60. I'll say Uta NAS. And we'll say 445. Okay. So we're going to run that test again. So what this is doing is this is going to go out. It's going to test our connectivity. It's going to do those basic tests that we set up. And it's going to make sure we can ping our local DNS server, which really we did down here, but we need to set up a ping. And it's going to test connectivity to both the network attached storage I have here at my office. And it's also going to test the network attached storage at Uta's office. So I can run this and I can very quickly tell that I have access to those resources I need. I've got my power over Ethernet. I've got my green bar up there at the top. So again, we're going to see that if I save this as a profile, it will save all these tests. I can go create another one, save that, create another one. This is a fantastic way to make sure all those resources are available that you need to have to get your job done. So how does it do this test? It sends a TCP SYN packet using that port number. And if that SYN packet makes it all the way through and we get a SYN acknowledgement back, then we get a green check mark. Now web, we could go in and have it check a web server. So I'll come back here and I'm going to go up to public internet and I'm going to say I want to do a web connectivity test. So my server, so we'll do enterprise.netscout.com and we'll leave that name there. We're going to transfer the whole page. Now we could come in and we could say, what return code are we looking for and what must be in the HTML and what must not be in there. So in this case, if we had a page come up that said we had an internal server error or something, well, we could say it must not contain that or we must get a 200 back. So I can click on this and we can specify which return codes we're looking for in here. So we'll come back. We'll go ahead and test that again. Now while we're testing that again, let's come back here. So the question is, how many user tests can be configured? So what we're going to see, and let's see if I show this in my slides. So this shows how we set that test up. We'll go back and we're going to talk about that. We'll look at our test results here. What you're going to find is that if we set up more tests than will fit on this screen, let me add 2 more. I'm going to do a web test here. So we'll say 10.0.0.108. We'll click on Done. We'll go back. Now we have filled up this line. Now if I click and hold and I add one more test, and in this case I'm just going to do a ping test. We'll say security cameras. Now, when I come back, notice that we have that little arrow right there, and there's a 1. So if I click on that, it tells me there's one more test off to the side. And there's my 2 tests. So I'm going to hit test on there. So we can fill these screens up. I haven't really run into a case where I've had more tests than this would be able to hold. And when we run our report, the test results will be produced for all of those. And like I said, where these are at really is just limited by where you want to put them. So I could put local tests up here or even up here. So it really becomes, how many tests do you want to put on there? I don't believe that we've really run into a limit as far as how many of these tests we can create. It'll just show us, how many pages we have to go through on there to flip through those tests. So in this case, we find out, we get our green bar. So even if those tests are off to the side, we still get our green check mark saying all of those tests passed. We get our green bar up here at the top. We have the connectivity that we need out here. Okay, so our web test, we can look for return code. So if I click on that test, this shows me what my results were. So it took me 1 millisecond to look up the DNS address. It took me 12 milliseconds to establish my TCP connection out to enterprise.netscout.com. Data start is the time from when I sent my HTTP GET to when I got the first byte of the return data. So this gives me an idea of what my server response time is. Data transfer, how long did it take me to transfer that whole enterprise.netscout.com page down to the OneTouch? This gives me an idea of what my bandwidth looks like. Total time, 104 milliseconds. I transferred about 60K bytes. I got a data rate of 11.8 megabits per second, bringing that page down. Here's my ping time. And we could arrow down here. Tells us what our wired IP, what the IP address was of the website, and what our return code is. So there's our results. And if we had our Wi-Fi turned on, it would show me the results for the Wi-Fi side as well. Go back to the home screen. Performance testing. So one of the tests that we can do on here is going in and doing a performance test. So for this particular test, we're going to come over here and we are going to use our link runner AT2000. Okay, so I'm going to turn this on, and this is a phenomenal little companion product that we can use in conjunction with our OneTouch. And I will fire up another OneTouch too, as well, as we'll use that as an endpoint. But in this case, on my link runner AT2000, now this has both a copper and a fiber connection on it. This is, the next step down from the OneTouch, right? So I might have every technician have a link runner AT2000 for doing some initial testing, and then a few people have the OneTouch, for example. But what I'm going to do is I'm going to come into my link runner AT2000 and I'm going to put it in reflector mode. Now when I put this in reflector mode, What this will do is this will reflect packets that it receives from the OneTouch back to the OneTouch, and it's going to allow me to do a throughput test. So I'm going to hit start. Now the IP address that I got on here is 10.0.0.166. So why do we do performance testing? We do performance testing because ping is not good enough. We do performance testing because we need to know that this Netgear switch that I have set up here in my little classroom supports gig. So we want to make sure we can do full line rate, full duplex gig through this link without any problem. So that's why we do performance testing. So what do we find out? There are two types of endpoints that we can have out here. We can have a peer, which is another OneTouch AT, or we can have a reflector, which is the Link Runner AT2000. So we've got the Link Runner AT2000. Here we've got the OneTouch. So let's go ahead, and if we're using a performance peer, we're going to set that up. Now, let's see. Let me just do a little quick wiring here. So we're going to turn on this other OneTouch that I have. And we'll grab a short little patch cable here. We'll hook up the management interface. Okay, so this is connected to 202. So what I'm going to do, I'm going to come into my VNC front end. Get this over here. All right, so here's my other OneTouch. So we're going to bring this up and get this ready to use. This is our OneTouch AT 10 gig. I'm going to steal the power off of this one and plug that in to power. And we are going to come into this one, and we are going to, oh boy. Okay, we're going to scroll down. It looks like I need to update the software on that, but I'm going to go into Performance Peer. I'm going to hit Start. So what I've done is I've started the Performance Peer on this other OneTouch. Okay. Now in this case, it just happens to be a 10 gig. So one of the questions, can I set up a performance test using port A and port B? I can't, but that's an interesting idea. We're going to see that something like that works with wireless. It says, can you use the OneTouch AT as a reflector? So what we're going to do is we can, in that it can be a performance peer. So we're going to set up a couple of different tests. So right now, we've got a OneTouch AT 10 gig set up at 192, and we've got our Link Runner AT2000 set up